So reminder that you are allowed to use an index card as kind of like a cheat sheet tomorrow. So feel free to get one. Feel free to just, I don't know, learn how to do it yourself and study and memorize the formulas. It's up to you. But that's something you can do to kind of give yourself a little cheat sheet so that maybe you don't have to stress as much about learning certain formulas. All right. But from either review, it could be the constructed response review, which is the packet which you are taking tomorrow for that part of the final, or it could be the puzzle piece review that you're doing on Monday for the real thing. Either way, today's like really the last day to ask questions. So any questions? Or is it straightforward? You already know everything. Camille?
Can you do question 3 on the test, like
The puzzle piece one?
Yeah.
Okay. So if you have not worked on the puzzle piece yet, or maybe you are, maybe look at number 3 so you can make sure you got it right. But number 3 on the final exam review in Schoology. Okay, so a teacher wants to examine students' test scores. Their scores are 64, 88, 78, 90, 94, 90, 84, 90, 98, and 80. Use the 1.5 times IQR rule to determine any outliers, if any. So the 1.5 times IQR rule is part of the formula for outliers. All right. So basically, from a data set, do 1.5 times the IQR, which what's the formula for IQR? What's the formula? So IQR interquartile range. Think of like what is normal range of the data set? What did you say, Jorge? Okay, the range is the biggest number minus the smallest number. That's just like your normal range, not even interquartile range. But normal range is a subtraction problem. You're doing your maximum minus your minimum. Interquartile range is also a subtraction problem, but you're subtracting your, yes, so make sure it's Q3 minus Q1. So it should always be a positive number for your IQR, but it is also like range is a subtraction problem. So minus interquartile. So you would need to figure out what your Q3 and Q1 are. And then if it is, well, I guess let's do that first and then see about the outliers. So on this data set, are they in numerical order? So first thing we need to do is put them into numerical order. So let's do that with the smallest number here. Then 80, then 84, and then 88. Right. 390. Yeah, 390. And then so how many did we start with? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. Okay, so we have all of them. That's a great way to check if you have all of them. Is count how many you started with, how many are in your list. And the reason I'm doing that is because in order to find your Q3 and Q1, what do you need to find before that? Your median of the whole thing. You don't need your mean at all for this one. But median, middle of the entire data set is gonna be sorry, I don't know off my head. I have to go left, right, left, right. And look, we have two numbers in the middle. What happens when you have two numbers in the middle? So 88 plus 90 divided by 2. 88 plus 90 is I know the median is going to be 89. That's the same as both of them, right? But 88 plus 90 is 178, and then divided by 2 is 89, right? Someone verify? All right, so it should be like in between those two numbers. So then the reason I write it out here is because now that I have like my lower half and upper half sorted out, my Q1 will be the median of my lower half, and you never cross out the median of the whole thing. So that's over here. So when we do our crossing out, it goes left, right, left, right. My Q1 is 80. What's going to be my Q3? 90. So left, right of now my upper half, my Q3 is 90. All right, and that helps us find our IQR. So then what's our IQR? 10. And then we times that by 1.5. What's 1.5 times 10? 15. So the rule is that if you're testing a lower extreme, so like if we're testing 74, that's our lowest number. If it is smaller, so if X is smaller than, and since it's on the lower end, Q1 minus 1.5 times the IQR, which we just figured out, like this portion would be 15. What did we say Q1 is? 80. What's 80 minus 15? 65. So then is 74 smaller than 65? No, it is not smaller than 65. So this one is not an outlier. Let's see if we have an outlier on the right-hand side. So like an upper extreme, because technically there could be an outlier on both sides. So now we're testing the 98. If you're testing an upper extreme, the formula is X greater than Q3 because it's on the upper half plus 1.5 times the IQR, which the 1.5 times the IQR we figured out to be 15. What did we say Q3 was? 90. What's 90 plus 15? 105. So is 98 greater than 105? No. So then that one is also not an outlier. That's how you can know for sure. Sometimes, and that's also one of the questions that's on your constructed response, not on the one I printed for you, but on the one that's online, just so you know. And the formula is there too, if you want to put that on your note card later, it'll be there later. But, and so will this recording. But, that's how you can know for sure. Some people just say like, oh, if it's like really far off, but there is a way to quantify that and know for sure. So for this one, no, there aren't any outliers. It says, what was the low cutoff limit? Well, 65. So anything smaller than that would be an outlier. And then what was the high cutoff limit? What was it? 105. That's what we figured out using the 1.5 times IQR rule. You just have to remember the Q1 and the Q3 and whether you add or subtract it based on if it's a lower or an upper. Okay, good there. All right, any others from either review? On this review? Okay. So number 2, it's really tiny. The table below shows the average monthly low temperatures in degrees Fahrenheit of 2 cities. Compare the sets of data. So this is a good one. I just wish I could make this bigger. So I'll just have to keep zooming in and out. But what's the formula for range? Just normal range. Good. So what is, and you have to find it for each one. So I guess we'll find it for Seattle first. What's my biggest number in that data set? For Seattle? $55 for Seattle is the biggest. And then what's the smallest for Seattle? Looks good to me. And then what's 55 minus 36? 19. Okay, 19. So that's the range. How about I do all of Seattle and you guys do Kansas City, since it's kind of like a U try. But yeah, so maximum minus the minimum, 19 for Seattle. Now, standard deviation. There's a way to do it by hand, but I didn't teach it to you by hand. How did I tell you to find standard deviation? And you usually don't learn it by hand in Algebra 1, by the way, but learn it in Algebra 4. But what's the only way we know how to calculate standard deviation? By using Desmos. So what you would do, and there's no way around it, either use Desmos, which you will have access to. At least that's my impression, that you'll have access to it. Sorry, the thing won't move. Maybe I'll just have to move it myself. All right, but either use Desmos or use a graphing calculator that you know how to use, and just make a data set in there. So I usually use D for data equals bracket and then type in your data. So for Seattle, it's 36, 37, 39, put them all in there, separate them with commas. Okay, so I think I have all of them and it'll tell you how many numbers are in your list. So you'll just want to go back and make sure that's how many data points you were given. So yeah, January through December is 12 months. So that sounds accurate. And then in a different cell, you can click this little keyboard down here. And there's a functions menu. Scroll down to statistics because that's what this unit was on. And there's actually 2 standard deviations. I just usually will use both. There's a way to know which one to use. One is for population, but you know, whatever. Sometimes they use them interchangeably. So standard deviation, either way, they're very similar amounts, as you can see. So I'm gonna freeze this and see which one it wants. I imagine it's probably the first one. Did someone already do this one and get the answer to it? And like get it right? Okay, so I'll check right now. Let me pause this. Standard deviation was 6.7 according to our graphing calculator. So use the standard deviation P, that one. And then IQR. What is the formula for IQR again? It's the interquartile range. Good. So for that, and Desmos doesn't find your IQR for you. It could find your quartiles for you, actually, but you should also know how to do them by hand anyway. But for that, you would need your data to be in numerical order. So what's my smallest value? 36, and then what? So I have those four. What's the next smallest? You guys can all pull it up on your own screen. I know it's tiny on mine. It's number 2. So 41, 43, 2 47s. 52, 52, 54, 55. Is that all of them? All right, I have 12. So then before you find your Q3 or Q1, you have to find what? Davin, before you find Q3 or Q1, what would you have to find? The median of the whole thing. Good. So from left, right, and since I had 12 data points, I should have 2 numbers in the middle. And that I will have to take the average of. So yes, 2 numbers in the middle. 43 plus 47, and then divided by 2. I got 45 if someone wants to verify, which makes sense because that's in between them, right? So then 45 is my median. That gives me my lower half now over here. So find your Q1. Again, 2 numbers in the middle. What's my Q1 going to be? 38.5. You could do it with a calculator or just think of what's in right in between them. 38.5. And now your upper half over here, find your Q3. What's my Q3 going to be? What's between 52 and 52?
52.5.
No, 52.
Oh, man.
Because if it's the same number and you're taking the average of the same number, it's gonna be that number. Or you could just add them together and divide by 2, you'll see. But yeah, so then IQR is Q3 minus Q1, so then do 52 minus 38.5. And that you get 13.5. So then you drag that over. How do you guys find the mean of stuff? What is another word for mean? Not median, average. Same thing. So the formula for mean, and that would be a good one to put on your note card if you don't already have it memorized. But to find the mean, you take the sum of the values and then do what? Divide it by the number of values. So everything in our list, you would add it all up and divide by what for Seattle? You would divide it by 12 because there's 12 data points. So real quick, I'm just gonna add it. Although I do have it in Desmos. Maybe, I don't know if it'll give me the sum. Whoa. No, it doesn't. Okay. Thought it was worth a try. Did anyone add them all together? All right, so I got 541. Someone else can verify that as a sum of all of Seattle's values. And then divide that by 12, because that's how many data points there were. And I get 45.1-ish. Or 45.08 is what it actually is. So there you go. And then the median we found earlier, but I forgot what it was. Do you guys remember what it was? 45, you said? I feel like it was a decimal. So I'll find it in Desmos then. Because in Desmos, you can also use the functions and type in median or use the median button and it can find your median. So it was 45. Sorry, my bad. I didn't keep it on my screen. All right. And then once you find the data for Kansas, I'll let you do that now that I showed you how to do all of Seattle and I recorded it so you could go back to it later if you need to. When it asks which city has more variability, what does the word variability mean? Kind of, no. More spread out, yes. It's a measure of spread. So more variability means more spread out. What measurements tell you how spread out something is out of these ones? Well, out of these 5 measurements, which ones tell me are measures of variability? This one's 1, so is standard deviation. One more, IQR. I think overall range can be misleading sometimes, so I would mostly just look at these 2. Whichever one is higher, so if it's higher for Seattle than Kansas City, then that one has more variability. If it's higher for Kansas City compared to Seattle, then Kansas City has more variability. So once you find that value, compare them. The higher IQR or standard deviation, the more variability it has. All right, sorry, that one was kind of a long one. I'm gonna come around and give you points for your packet. So when I come around, just flip through the pages for me.